So when solving a conservation of energy problem, the biggest things to look for is the fact that the track is frictionless, because if there is friction, then energy will not be conserved. So make sure that every problem you have, which everyone you should be frictionless. But remember, the big ideas here is the total mechanical energy is equal to the kinetic energy plus the potential energy at any given location. So let's read a little bit about what we have. We have a Hot Wheels car that has a mass of 0.3 kilograms, is released from rest, so the initial velocity is 0, which that should indicate to you that at the very top up here we have no kinetic energy. So all of our energy up here at the top is potential. At point A, which has a height h, the car is observed to have a velocity of 2 meters per second at point C. So our velocity here is 2 meters per second, which is 1 meter above the ground. So that's going to be our height at that location. That's all the information that we know, and the idea that total energy is the kinetic plus the potential at any given spot, and the idea that this energy is conserved, so the total energy never changes. So our first part is calculate the total energy at C, which is going to be equal to the kinetic energy at C plus the potential energy at C. So to calculate potential or kinetic energy, it's 1/2 mv squared plus the potential energy, which is mgh, and this is all at location C. So we have 1/2 times the mass, which is 0.3. We know that at point C we are moving at 2 meters per second, and don't forget to square this velocity, only the velocity is squared, plus the mass, which is 0.3, times the acceleration due to gravity, which on Earth is 9.8, times the height, which is 1. So we can take all of this and plug this into our calculator. So we have 0.5, well, let's do some parentheses, 0.5 times 0.3 times 2 squared plus, open parentheses, 0.3 times 9.8 times 1. And that gives us a total energy of 3.54 joules. So our total energy is equal to 3.54 joules. Now that is our total energy at point C, but as we know, energy is conserved, so that energy is the same everywhere.